is Frédéric Raget. He's a Chief Operational Officer at Turbulent Hydro. And Turbulent, it's a company that has developed a way to harness the energy from rivers and canals with a low height difference. And today he will present us his experience from some projects in which they are involved to implement the technology. Welcome, Frederick.
Thank you, Doris. So, what do we make? We make micro hydropower. Why do we make it? Still all over the world, more than 700 million people have no access to reliable energy, so no electricity. We all talk about it a lot, but at the end, the most fast solution is get a fuel-based generator on site and they have the energy they need. So we have a solution for it. As I come to say, we have now three regions where we are very active in, and I'm gonna mention those three because they are all already in working phase, so I can speak not only by studying it, but also the proof of concept is there done. Here in South Africa, there is really a load shedding issue. Most of the people here have energy, but not reliable energy. We have here a project with two farmers, big farmers, where we produce the energy for the irrigation pumps. The irrigation pumps is their main source of income. So they need reliable energy. In Kenya, we have a nice working system where we provide energy for communities, for hospitals, and for tea plantages. 70% there of the population has a grid connection, but more than 30% still has not. So the opportunities there are very nice. The Philippines, due to their 7,000 islands, all their systems are off-grid. Most easy way, you put on each island a small generator and they have energy. That's what we want to avoid. What is our solution? Hydropower. So we address it with hydropower, small hydropower. We use what nature gives us. If we have a small river with a 1.5 CMS on water and a small drop, we can produce energy locally. So not decentralized, but really on the spot where people need the energy. We don't big dams. You will see it in the next slide. If it's working. So we build it on the spot, really on site where they need the energy. We don't build the big dams. We don't need 4 years of permitting phase. We only need 6 months to build it and to bring them the energy they need. If they need now a small amount of energy, we can deliver 1 turbine, 2 turbines, whatever is needed. If they need more in the future, you just add a few. So no big transmission lines, no big dams, no harm to nature, just a small footprint aside the river, and we can go on with it. How do we do it? We take the water out of the river, we drop it into our basin. The basin makes our turbine spin, and the energy goes back by our cabinets to the population. How does our turbine look like? A little picture of it. So we need a generator, completely submerged. We need the impeller to make him spin, and we need a connection to the grid. Or we can go off-grid, then you don't need them. Up on 2 years ago, we made everything custom, but it was very costly. So now we set up a standard of 5 turbines, 15, 13, up to 90 kilowatt. We can make them modular, so we can install many megawatts if needed, and if the river provides us enough head and enough flow. A little bit, as I said, how the system works. So we take it, we use the water to generate, and we give it back to nature. We are fish friendly as well, so we have made tests in the UK, and fish passing by harmless. A view on the turbines that were sent now 2 months ago here to South Africa. So as I come to say, we are now producing with standards, not custom anymore. So we can make them a little bit more off the shelf, makes it cheaper and more affordable for the people who needs it. Cost effective, we produce at an LCOE of 0.04 euro cent a kilowatt hour. It means that a normal system, good working system, under conditions here in South Africa, the payback time is between 4 and 6 years. In contradiction with diesel-fueled generators, you don't have the logistics to bring the diesel, you don't have all the pollution that is concerned with it. Where are we active? A little bit all over the world, but as we have to see now, a little bit too much. So we have now 3 focus regions. We are focusing on Eastern Europe, on Africa, and on Asia, Southeast Asia. If there's something else coming on, we still go on with it, but it's not a focus anymore. Due to the capacity we have, we are a small company, and we have to see that we can manage financially. The impact we have on the SDGs, as you see, quite a lot. We have economical impact, we have social impact, and we have, for sure, environmental impact. Some cases, this is the one in Kenya. It's an installation of 3 turbines, 3 times 37 kilowatt. It provides energy to the local communities, to the local households, to a hospital, tea plantages, and some schools. This was a nice project in combination with the Flanders support by VIKAP. So that's in the case in Kenya, where we provide energy to the communities, and where we have now a very nice installation delivering sustainable and reliable energy to the locals there. What is the scope? As I said, there were 3 turbines, where we have the financial support by a partner, local partner, Hydrobox, and by the Flanders program on climate change. So over there, we reduce more than 200 tons of CO2 a year. The impact on households, as I said, and we provide it to farms, to businesses, and to hospitals. The case in the Philippines, this is a larger project. They are building it now. Installation is by the end of the year. Turbines are already shipped. It's 8 turbines in parallel. Why in parallel? Here it's specifically what I mentioned, a modular system. So we can produce enough energy here to the local rice farmers. They need the energy, but we have a small drop, only 3 meters. But we have a lot of water because we are working on an irrigation canal. Due to working on the irrigation canal, we are provided all the time, 24/7, of more than enough water to keep the system running. We don't involve the rice farmers itself. We just provide the energy to the local grids. So they have the energy they need. And we add more than enough energy to the grid to make it stable, what at this moment was really an issue. Here, the money doesn't come from Flanders. Here, it is really a case where the money comes from a local entrepreneur who wants to invest in this system, and his payback time is 7 years. He provides the energy at 30% lower price than national energy companies in the Philippines. So to give you an idea, it's profitable to go on with it. This gives a little bit of view of it. So we use the water of the irrigation canal, we let it pass by our turbines, and we give it back after the existing dam. Here, why the existing dam? They build it every 3 kilometers to get enough irrigation water draining to their rice fields. And now we have an upcoming project to deliver the same system on each dam following the next 2 years. Our local impact, here the same. So we are on grid, we provide energy to the local grid, and we make it reliable for everybody over there. Where is it used for? Just for local people. Nothing more, nothing less. The irrigation canal is already there, so the construction was minimal. Third case, South Africa, KwaZulu-Natal. 2 farmers, they want to invest in reliable energy to make their irrigation pumps running. So those 2 farmers invested in the 3 turbines we are installing here on the spot. You will see a picture on the next slide. Here the same, by load shedding they have issues, and by providing more than enough energy to their local system and to their local grid, we can go off-grid for them, and when the energy is too much, we send it back to the grid and make it stable again. We reduce here more than 1,000 tons of CO2 every year. No dams needed. We use what nature gives us. This is an existing waterfall, a big one, where we install really on the cliff. You see the picture aside. It's 30 meters deep. Quite a challenge to build it, but it will be built within 1 month and finished within 1 month. So it's feasible. And we use the water as it is now. So no dams, we just take it and give it back to the river. Same, we needed here in South Africa a pilot case to show that we can work hybrid, because that's what future is essential. So don't think it's only solar, don't think it's only hydro. If we combine it, we can deliver 24/7 for everybody energy. This is the proof, this is a pilot case, and it will be in use within 1 month. So the scope, 3 turbines here in South Africa, hybrid with solar, paid partly by Flanders, paid partly by an independent farmer, and running in 1 month. What did we learn of it? 3 things. First of all, technical. As I say, custom is one thing, we still can do it, but why standardizing? Because it's cost effective, it lowers the price. CapEx is most of the time an issue for investors. In Europe, they want to invest more and they think a little bit further. In Africa and in Asia, the CapEx needs to be very low because they will choose the most cheap solution and the fastest solution. So that's why we go over to standardized solutions, standardized components off the shelf and made in a few months. Hybrid technology, also important, as I came to say, combine the solutions that are existing and you will win in the future. Financially, don't try to build a financial case during the project. Make it happen as we deliver it upfront. We provide their financial solution. We provide their financial model, their business model, and it helps because most of the time they don't think beforehand, they will think afterhand. Cost effective, as I come to say, the most of the times we need the fastest installations, so we build, we install, and we commission within 6 months. Social, same, we always try to work with the locals. For the local entrepreneurs, we need contractors, we need maintenance people, and we need local investors. We go for it, we try it out, and we see now the more and more, the more they are involved, the more they are capable to continue afterwards. The system doesn't remain there. They start to maintain it, they start to operate it, and we are less involved than before. We still have a look what is going on in Leuven with us in Belgium, but the more and more they can do it by their own. Stakeholders collaboration, that's what we are trying to do. We go to universities, we go to technical schools, we have a look on what is available on site to give them the chance to go on by their own and not only relying on us. As I just came to say, scaling pod, that's what we're standing for. So not anymore by engaging a lot of people on our company. The more and more we work with local agents, those local agents are very well trained. They have the knowledge and they can install, invest, and commission themselves in the countries where we are active. Thank you for this. And I thank you very much for also Flanders with the VIKAP project. They were a big support for us. And here our local partner in South Africa, that was Iretech. If there are questions, willing to answer.
Thank you, Frederick. The questions, we will take them at the end of the different presenters together. Now the next presenter, it's Laurens Devers from Waterloo, Regional Director Africa. And he will present us, so I should say Waterloo, it's a utility company based in Belgium, but is operating globally. And he will present us the example of the capabilities of the process in relation to renewable energy production and its valorization then to tackle climate change in the industrial context.
Thank you for the introduction. Hi, everyone. So my name is Laurens. I'm working for Waterloo. I'm the regional director in Africa. So Waterloo is indeed a utilities company. So we are a Belgian-based company specialized in water treatment, effluent treatment. A little bit as BOSAC before, but BOSAC more focused on water treatment, compact drinking water treatment plants. Waterloo more focused on bigger industrial applications and municipal applications. And 80% of our business is on the effluent side. So effluent, water recovery. We do also drinking water treatment plants, but when it's in combination with effluent treatment, effluent recovery plants. So we as Waterloo, we're based in Belgium, but we have around 75 engineers in Africa, of which 25 here in South Africa. So we have around 150 projects now in Africa. Mainly for the big food and beverage players. So we work a lot for Coca-Cola, Heineken, AB InBev. Today we are constructing 2 plants here in South Africa. One is for Cirrus fruit juice. You might know that one in the Western Cape. Building a big effluent treatment and recycle plant for them. And also AB InBev here in Rodepoort, the Shamdor brewery, where they make all the Stella and the Hoegaarden. Some of you might know we also do a project there. Today, I'm not going to talk about those projects, but about another project in South Africa. As the topic today was decentralized systems, this topic goes the closest to the decentralized system because it is a joint venture between Heineken. It's on the plant where they make all the Klipdrift. You might know Klipdrift, it's made from wine. And together with Brennochem, they formed a joint venture to have a full effluent treatment and water recycle plant. So those are 2 companies. The project is in Worcester, in the Western Cape. And Waterloo built the plant, and now we operate and maintain the plant. So we have permanently 10 people there, maintenance, spares, operations. We do everything for them locally. So it's a joint venture, and the client looks at us because the one client, Brennochem, they are a chemical company, so they take wine waste. As you know, the winelands in the Western Cape, there's around, 86,000 hectares of wine. All that wine gets processed by the different wine houses, And then there is a company called Brennochem who takes their waste from the wine, and that collects in their factory, and they make from that wine waste different chemical products, citric acid, tartaric acid, which they sell again on the chemical market. And the waste from that comes back to us, together with the waste from Heineken. Heineken, who bought Distel and who makes Klipdrift there. So there we installed a very large 45-ton COD per day, so that's 1,000 cubic meter per day, effluent treatment plant. So that is treating all that wine waste plus all the effluent from these two factories. The process is not that complex. It's a buffering, then digestion, a biology, an MBR. And then there's the RO, where we produce back potable water back to the factory, so full recycle of potable water. And after there's a biogas reuse, and it's especially on that biogas reuse that I'll talk a bit more today. So these are some pictures of the plant. So the plant was built in 2019, so it was a 120 million rand project. Because the sites wanted to be compliant. So Distel, together with Brennochem, decided we want to be compliant, we want to discharge our effluent compliantly into the environment, and that was the main driver at the time. It was a drive for compliance. Today we see that there is a water recovery as an economic driver, and there is also a biogas recovery, where they recover the biogas from that effluent and put it in their boilers and generate steam from it. And that has, as we will see later, a net carbon reduction. So we as Waterloo, we do the full operations there. It's a full system. This is a operational system. So we go from the buffer tank to the digester. The digester, that's the main item where 80% of the pollution is reduced. So 80% of the pollution is there transferred into methane, into biogas, which we will then reuse. And after the process goes into a biology, an MBR, and then a reverse osmosis. So just a little bit on the reverse osmosis, and then I'll go to the biogas reuse. So we make back potable water for the client. So there's around 1,000 cubic meters of effluent coming to the plant. That's 1 million liters a day. And out of that, after digestion, after MBR, after RO, we produce fully ISO-certified potable water again. So that water is free of any pathogenics, any viruses, any bacteria. It's ISO-certified. There was a visit of the Flemish Prime Minister there in 2020, and he drank from the water, and as I know, he's still alive today. So to let you know that it's fully safe. He's also paying a lot of the salaries here today, so he's still alive and well. So that water gets recycled fully back to potable water. So that means also that the discharge out of it to the environment is only 20% of what it used to be. 20% of the volume, which almost no pollutants in there. So, and then to the biogas reuse, that's a recent project that was added onto the existing project of 2019. There are some challenges. There's a high sulfuric content. There's a high seasonability in production. As I said earlier, all the waste and the wastewater is coming from wine production, and the harvest is January, February. So we see a big peak here in the beginning of the year. There's a big peak in seasonality where all the waste from the different farms, after they squeezed out the juice to make wine, comes to that plant, and that's when we see a peak. And then there's like a dead period in June, July for 4 or 5 weeks where there's absolutely no activity. We then again an active period for 3 months to stop completely end of November. So good for the employees there, but November, December, January, there's no production, so they can all go on holiday and come back somewhere end of January when all the production takes place again. So luckily for them, the seasons fall good, that the grapes are growing in summertime, and that's December, January when it's also holiday period. So the business case was based on the following numbers. I don't know if it's large enough, but today the biogas initially was flared into the big flare which you see on the right, and we added a project there where in total they save around 20 million rand a year now in a reduction in coal. So they save around 3,800 tons of coal a year. That comes from Mpumalanga, Limpopo, all the way down by the N1. If you ever drove on the N1 and you see the big blue trucks, those are the trucks carrying coal down to the Western Cape. So that's 3,800 tons of coal a year less that needs to be transported. And that translated in a net reduction of coal costs of 11 million rand. And on top of that, carbon credits that they were able to get of 9 million rand. So in total, that's a saving per year of 20 million rand, 1 million euro. And the total project costed 30 million rand. So the add-on project. So the add-on that we did this year. So the commissioning happened in August of 2 months ago, so of this year. So the return on investment is 18 months. So it was a no-brainer for them to go for that. On top, since Heineken is one of the shareholders and there is a new legislation in Europe that by 2035 all big companies need to be carbon neutral. So that also helped in their global ambition to that. So what happened? The installation that was there, I can actually do this. Yeah, no. Yeah. Yeah, and so this was the installation that was there. This is the main reactor producing the biogas. What we then did, we added drying, compressing, and a desulfurization unit. Very technical to go in all the details of it, but basically the biogas that comes out is methane, or 60% of it is methane. It was now going to a flare, where it was just flared and turned into CO2. What we do, we dry it, we compress it, we take the sulfur out. So why? Because the sulfur is very corrosive and it will corrode your piping and your boilers. So that was taken out, and then it goes to a biogas boiler and it turns into steam. So these factories, they need steam because making clipdrift, making rum is a distillation process. For distillation, you need heat. And that heat was previously generated by coal. Today, as you see the cross, which is not entirely right on the picture, but that's a detail. Today, the coal consumption went down with 3,800 tons, which is around 35% of the demand. So they saved 35% of the demand in coal by changing it into biogas, which is a byproduct of the waste. So that's today. Today that is installed and commissioned, and as you can see, the return on investment is around 18 months. And the last thing, we fully operate and maintain the plant together with our Smart Lab. So Smart Lab is our digital platform. We move into a digital world, so we track the entire system from distance from our smartphone with different KPIs, with dashboarding worldwide. So we follow remotely, and we have operators on site, but the clients can also follow remotely what is happening on site, are the KPIs reached, how much OPEX are we saving, and we do that both for industrial applications and municipal applications. So in Africa, as I said, we have around 150 installed base plants like this. Around 70% is for industries, 30% is for municipalities. So we also do a lot of work for municipalities. And more than half of the systems today are on our Smart Lab, where we visualize and have trending on the different parameters. And that results in stable operation, chemical savings, and energy savings. So that was my presentation short for today. I know the questions are after, but I need to run to the airport at 12:45 because I need to catch a flight. So thank you, everyone.
Maybe if there is a burning question for him, we will take it now as he has to run. Otherwise, no? Okay. So we continue with the next speaker, Ruba Onesi, Project Administrator at the Division of Energy and Climate Action at the United Nations Industrial Development Organization, UNIDO. And she is following projects mainly here in South Africa, which she will be presenting today with the supporting to accelerating the sustainable development of South Africa industries. Welcome, Ruba.
Thank you. Hi, everyone. So I will be presenting one project that UNIDO implemented here in South Africa and focusing on the water energy nexus. But first, for those of you who are not familiar with UNIDO, so UNIDO is a specialized agency of the United Nations with the mandate to promote inclusive and sustainable industrial development. And we support stakeholders in different areas of intervention, including technical cooperation, policy advisory, and fostering partnerships, etc., with the aim to build an environmentally sustainable industry, economic competitiveness, and shared prosperity. Zoom in at the Energy and Climate Action Division of UNIDO, where I am based. The division works with developing countries to accelerate the transition to low-carbon, climate-resilient economies. And it works on three main axes. So low-carbon transformation of the industrial sector and decarbonization of heavy industries, building resilient supply chains for clean energy technologies, and enhancing energy access for industrial development. So coming to South Africa, where we implemented the project that closed last year, and just to present the rationale behind it. So South Africa is one of the driest countries in the world, and faces a lot of challenges with regard to water and energy access. So they suffer from unreliable energy, also high climate risks. So this is the importance to support local industries in South Africa through the adoption of renewable energy, water use efficiency, and energy efficiency measures to enhance their climate resilience. And in this project is seen from the lens of so the water energy nexus, because water and energy are interdependent, and so we're trying to really look at both at the same time to have integrated holistic solutions to best support the industries. So what does it mean in the industrial context? Climate resilient is the ability to absorb the stress imposed by the climate change impact, and to implement and adapt new pathways, more sustainable practices to be better, to help the industries be better prepared for climate change impacts. So the project is called Strengthening the Climate Change Adaptation Capacity of South African Industries. And so the objective is to support industries to adopt green and climate technologies and enable the proper environment for that. The project was funded by the government of Flanders, and it was implemented from 2022. It closed last year in December 2024. So to summarize what the project was focusing about, so the main takeaway, so we had call for proposals to implement pilot projects to demonstrate the impact of these solutions. So we had 4 demonstration projects implemented in South Africa. 15 companies were supported with water and energy audits. We had the accelerator program in cooperation with TIA, Technology Innovation Agency, South Africa, to support green entrepreneurs and innovators through technical assistance and also financing, in addition to capacity building and trainings for different local stakeholders. There's also an energy and water baseline guideline that was developed in cooperation with the NCPC in South Africa, focusing on the agro-processing industry. And for those of you who are interested, you can download this from the CSIR website to read more about it. So to give examples of the demonstration projects that were implemented, so the first one with the Afrimat HAMP, so the project supported the installation of a containerized decortication plant. So the company is specialized in the production and processing of hemp as like an alternative sustainable material for used in buildings and other sectors. The second example was the commissioning of a biogas plant to produce biogas from agricultural waste, waste coming from the farm, from the piggery, pig waste, to produce electricity. The third example is in a winery that implemented different solutions in parallel. So first they switched to electric vehicle to reduce their CO2 emissions for the operations on the farm and the winery. They also installed a bioreactor to treat the wastewater, the effluent coming from the wineries. And then the accelerator program that supported the entrepreneurs and the innovators, so through technical assistance and also financing, mainly, for example, supporting these small companies to develop and enhance their business models, etc. The first one is focused on converting biomass to energy and also fertilizers. The second one is specialized in the production of products based on butternut and pumpkin, and they wanted support to make their production lines more sustainable, so they were supported for energy and water efficiency within their production line. And lastly, the last company works on valorizing liquid waste, mainly oils and fats. Yeah, I think also liquids from waste from dairy production as well. Production of biofuels from the liquid waste. Yeah, thank you. I try to keep my presentation very brief, but if you are interested to learn more about these projects, you can always go to the website of CSIR and learn more about them. Thank you.
Thank you, Ruba, for sharing these projects. And our next presentation and the final one, it's by Luyanda Naleda. I hope I managed. She's a senior researcher at CSIR. She's based in Cape Town, working in FICO remediation technology and more general other remediation technologies. And she has experience in algae culturing and is interested in implementing circular economy, as you will see. And she will talk today to us about nature-based solutions and for water quality improvement. And this is very interesting, as it is one solution that utilizes less energy than other treatment solutions, while at the same time also brings in other opportunities of valorization. And I welcome Luyanda.
Good afternoon. Thank you for the introduction. I will be speaking on nature-based solutions for water treatment. So just as a brief background, there are lots of issues basically compounding the ability for South Africa's adequate water service and quality delivery, aging infrastructure, load shedding, climate change, and as such, for such kinds of challenges, we need equally robust and efficient solutions. So we are looking at the concept of nature-based solutions, the idea being nature being able to heal itself. And in our context, it's the technology of phycoremediation. So phycoremediation is basically the use of algae to treat or remove pollutants. And from our research, we found that under aerobic conditions with very little mechanical aeration and regular dosing, we found improved water quality, improved diversity of invertebrates, and the potential for emerging contaminant removal. So the research basically began about 12 years ago. We started just co-culturing the algae at lab scale. We found that a co-culture worked better than the individual cultures of chlorella. We then upscaled the growth of the biomass in the lab and tested it under lab conditions against sewage. And we found a 70% reduction in phosphates and nitrates, which was quite promising. And that led to our piloting of the technology in more disadvantaged communities. So this is just, I hope the pointer works so that I can show. Does it? Is it getting there? It's everywhere else but where I want it to be. Okay, anyway, after that image of the bioreactors, they are just an example of one of the sites where we implemented the technology at pilot scale. And right below that is what the ponds look like when they are dominated by the chlorella species. So what we've also tried to look at is how do we harvest the biomass after treatment? So trying to look at how we can then repurpose the algal biomass for rebeneficiation purposes, so kind of closing the loop in terms of treatment. We've also supplied municipalities with basic training materials. So on my right, which I think is your left, will be an example of some of the materials supplied to municipalities where low-scale operators can also basically maintain the technology. So just by looking at the basic color scheme coding to know when the algae are ready for dosing into the ponds or when they require additional medium, which we supply to them on an annual basis. And we also then support them with providing them new cultures every now and again. So the studies have been implemented in 4 pilot sites at the moment. Our very first pilot site was in Motetema Wastewater Treatment Works in Sekhukhune. We've also worked with Pieterfontein Municipality in Matsekama. And we, through GEF funding, were able to do some feasibility studies with some of the SADC countries. And we had a pilot site in Malawi and ended up doing some feasibility studies for potential implementation in Namibia and Mauritius. Our longest monitoring site, or where we've had the technology implemented and monitored the longest, is in Mossel Bay Municipality, which is in the Western Cape. And that we implemented the technology in 2017 and are still monitoring and working with the municipality to date. So this is just a layout of Mossel Bay, just to show an example of one of our pilot sites. So it consists of 7 ponds, and we have aerobic conditions in pond 3, and that is where we start dosing. So if the pointer would allow me to, it's just going everywhere else. But we start dosing in pond 3, and that's when the algae start dominating. And then as the algal concentration increases, we expect then an improved water quality output in the end. At the end of the outlet of pond 7, the water is then repurposed for irrigation. So how efficient has it been from the science perspective? So just looking at a few, in the interest of time, a few of the chemical parameters that we normally monitor and measure. We've got pond 7 as just a reference point from the first time we implemented the technology, and our latest sampling results from July 2025 from the inlet pond 2 and the final effluent in pond 7. And we can see that there is about a 70% reduction in total nitrogen. We've got a 90% reduction in turbidity, and we've also got an improvement in pH and conductivity. So generally, we would say we are seeing significant improvements in water quality from a chemistry perspective. And this is just contrasting over the past 8 years of monitoring, showing some consistency in terms of the algal performance. From a microbiological standpoint or from a pathogen standpoint, we use E. coli as our indicator organism for pathogens. And when we first implemented the technology, we had a consistent log 4 reduction over the first year of monitoring, which is the first batch of results that we obtained. Our latest results, which were taken in July of 2025, we found a 3.8 log reduction. And this is interesting because this was in winter, in the peak of winter, and it's one of the most challenging times for the algae to perform, but we still had relatively consistent in terms of the pathogen reduction, or the sentinel for pathogen reduction. We also found that the Daphnia increases, so we've got an increase in biodiversity as well as the algae continue to dominate. So, and I think this is important to raise because Daphnia is one of the sensitive bioindicator organisms, and so that's an improvement in water quality. So we've got about a 10-fold increase of Daphnia from between pond 5 and pond 7, which is the final outlet pond. And then what is the potential for this technology to remove emerging contaminants? So we did a baseline study about a few years back at Brandwacht looking at the overall microbial resistance profiles in the ponds. And we found that there was a high resistance in the sediment and also in the surface water to sulfur methoxazole. As such, we then conducted a study with JPI, including other consortium partners from the EU, and we looked at common emerging contaminants, specifically antibiotics, and we then did a lab scale test looking at how the algae can remediate some of these antibiotics. And so over a 10-day period, we found that there was a very good reduction efficiency of environmental concentrations of antibiotics, specifically sulfur methoxazole and ofloxacin. For the others, we really could not quantify the measurement due to the instability of the actual antibiotics. So we found that there was a good reduction, which also then brings us to the point that there is potential for emerging contaminant removal beyond just the antibiotics that we have tested. So what are the challenges and prospects we found? We really need to optimize how we harvest our biomass. It takes a very long time to dry it. We've tried to use very low energy kind of approaches. And so because of the weather, rainfall, and those kinds of things, we find that it takes a very long time to harvest the biomass. And because of the cell size being between 2 to 10 micrometers, we can't always efficiently settle it out of the solutions or out of the effluent. So we really need to look at that, and also to optimize how we actually culture the chlorella species. So we're looking at solar bioreactors to maybe speed up in terms of the time that it takes for us to get a reasonable amount of biomass. One of the key challenges is the fact that the most vulnerable municipalities or communities are the ones that need the technology the most. And you find that they are not in a position to actually put funding forward towards supporting this. And so then it becomes the CSIR constantly maintaining and supporting these municipalities. And that is where funding becomes critical for us to further enlarge our footprint and also upscale to larger treatment plants where we can have more biomass to actually harvest. So some other important linkages and further opportunities that we have here is looking at basically expanding our knowledge base within the domestic effluent space and trying to optimize how we reuse or re-beneficiate our algal biomass. And also we've done some preliminary testing on industrial effluent. And we've gotten some promising results from some of the paper and pulp effluent that we've tested. And more recently, we've also looked at a human health perspective, where we found that the algae have an ability to sequestrate and reduce the virulence of Campylobacter, which is linked to Guillain-Barré, which is a life-threatening condition and sometimes fatal. And so we want to see how we can further expand that through these low-cost kinds of technologies. And yeah, so those are just some of the lessons we have learned, and that is where we are in terms of expanding our knowledge and our footprint in this kind of research. And yeah, that is me. If there are any further questions, I'm happy to answer them. Thank you.
Thank you, Luyanda. We have now 10 minutes for questions. If you have questions, please let us know. Yeah.
Hi, I'm Jane Maloney from the pulp and paper industry. Luanda, I'm interested in which pulp waste you used or pulp effluent you used. You don't have to tell me now in front of everybody if you don't want to. And I also just want to make a comment that it's been an absolutely fascinating session from the beginning. I felt sorry for the guys at the beginning because we didn't really get a chance to ask questions. But it was very enlightening. And this young woman next to me and I decided that we would give our money to any project that the Mozambican, he did such a good job of the presentation. But yeah, you can chat afterwards if you don't want to chat now.
Yes, because of non-disclosure agreements, yeah, we can speak after the session.
Other questions? I do have one as well for you, Luyanda. You said that every now and then you need to add chlorella culture. Why is that?
Because we need to keep them dominating the system. So what happens is over time the cultures will get old, and because of the volumes reducing, we always want to supply the municipality with a fresh batch that hasn't been contaminated. This is happening under open conditions, open field conditions, and so over time we just need to ensure that we have the right strain dominating.
And because of the valorization of the biomass and the risk associated with antibiotics, have you looked into it, if then it's in the biomass and if it could pose a threat?
That is where we are now. What we need to do is to adequately harvest the biomass. So we need to have enough biomass so that we can actually do a nutritional assessment and then find the best fitness for repurposing. So at the moment, we haven't been able to do that because we're not able to harvest enough biomass over a short period of time. It takes weeks, sometimes months, because it doesn't dry enough and we are not able to collect as much, and we don't really want to introduce flocculants because I feel that is counterproductive to the whole purpose. So we need to find a green solution in terms of better harvesting it, and that is what we're trying to do now. And that is why in the slide, I couldn't really read through all of the lines, but one of the avenues we're looking at is combining it with actual plant material. So we're thinking of adding an additional phytoremediation step, and then maybe we have more biomass for reuse and see what that looks like.
Thank you. There is one question.
Good day, everybody. This is Genesis Pasha here speaking. Okay, I'm sorry that I arrived late. The only thing is that, okay, that's not actually my industry, I'm in the telecom space, but I was in China for quite some time, so I just arrived back into the country. Now, the reason why I'm actually interested in the water topics is because of, it's an essential service for the country, and, we have a lot of problems all over the country for water. Now, what happened was, while I was in China, I was meeting a lot of different people from different industries and sectors, and then some of them, they were actually investors in water purification, let's say from the seawater, including the dams or the rivers. and during the water, industrial water and mining, just for rehabilitation purposes. Now, I remember I once held a meeting with, is it Anthea? There's Anthea here at CSIR, right? Is it Anthea Mbele? I think she's the head of water services around here. So we held a meeting with the guys in China. So one of the reasons why I actually want to to talk about this is, should there be probably anybody that maybe would like to have that sort of discussions or collaborations with those Chinese guys with regards to making sure that we have purification of water in the country, or maybe they have programs that might be in alignment with them. I think maybe it is something that we can have a chat about, because if they really want to come into the country and make a difference as well, and then have their programs that they're busy running in different countries all over the continent. I think that are just my 2 cents in this topic. Thank you.
Thank you for the comment. I think it's better then to discuss it with water responsibles here from CSIR. We can do it at the end of the session. Other questions?
The hydro guy. I was just interested in, you probably told us, but the amount of flow that's actually required.
Yeah, which is the limit?
The amount of flow starts at 1.5 CMS. At 1.5 CMS, you can start up a 15 kilowatt turbine, and we go up to 2.9 CMS to let turn 100 kilowatt turbine. Cubic meters a second, yes, correct.
And which is the limit to install the turbines? Is it the width of the channel?
No,
or?
you can play on 2 parts, or if there is more than enough head, it means when there is a drop bigger than 1.5 meter, even up to, like I have a project in Indonesia where we go over to 100 meters of drop, and there we will install 26 turbines in series. Or when we have a low drop but a lot of water, we can place them in parallel. And then we use one drop with several turbines in parallel, like we do in the Philippines. And there we use almost 35 CMS, cubic meters a second on water.
And then it's the width.
Yes, then it's the width that counts, yes.
Thank you. Additional questions? Okay, so with this, I will close the session. Sorry, before Rembo will give us a wrap-up with some key messages from the discussions, and then we will close the session. Sorry.
Afternoon, colleagues. It's Rembo Magoba here, manager for the Water Center here at CSIR. Thank you to all the speakers. It was very interesting. Mine is very easy. It's not something new, but to just summarize some of the key messages from the presentations. This includes part 1 and part 2 of the presentations. So starting with part 1, I'm using the names of the organization where the speakers were coming from, so that we can also remember where those presentations were coming from rather than the name of the presenters. There were some similarities between the presentation from Annabelle and Ricolto. They emphasized the importance of combination of both financial or business models and also the ownership of the installation. There is a need, of course, to push for the capacity building or training, apart from just being technically functional or operational. I think the issue of training and capacity building came up more often from the 2 presentations. Also, they talk about the importance or the need to contribute to the community development for their improved livelihood. Lastly, there was a mention that the choice of technology should depend on water quality, the population size, and also the affordability. Specific mention was done regarding the future budgeting. More often we do come up with technology, but without consideration of how this technology will be sustained. So I think it's very much important when we consider budget, we don't only consider the implementation part, but to consider the sustainability of that technology. The other presentation given by Bosak, it highlighted the multiple water challenges. It was very interesting to see that too much water is a problem, too little water is a problem, and too dirty water is also a problem. So that was very catchy. We need to address all those challenges. We need to also be mindful of the cultural barriers when we are solving such problems. There was also another mention of capacity building, where the implementations of all those initiatives needs to incorporate capacity building and also making sure that we address the social impacts associated with those projects, especially for women. When we deal with the water, especially in the African context, it's mostly women and young ladies who are responsible for fetching water from far distance. You hardly see men taking responsibility for collecting water in the African continent. We also had a presentation or presentations from Vito. I consolidated the take-home message for the two presentations given by Vito colleagues. There was a specific mention that selection of the energy storage for water systems, it's very much critical, and there are a number of things that we need to consider. Optimization of the system and the energy management that will allow maximization of the surplus of energy that is available. So as and when we generate energy, sometimes there is surplus energy. We hear about them taking back some of the surplus energy to the grid, which is a good thing in terms of stabilizing the system. We also heard about the importance of service that support the development of the community. So as we generate some of those energies, the most important part is not us running our technology, but also looking at the importance of supporting, especially the rural communities or those remote areas that does not have a good electricity supply. They can also benefit from the energy that we are generating from our operations. It was clear that the scaling up of off-grid services is more complex than it looks in the piece of paper. The community needs and local context are critical for off-grid project design and development. So we move on to the part 2 of the project. Unfortunately, we didn't have a break for those who were sitting here from part 1. We apologize that we had a straight presentations. Then when we entered into part 1, then there was presentation from Tablet, which was very much interesting on how they generate energy without really having infrastructure in place. Infrastructure, I mean that they don't necessarily need to develop the natural system, but they make use of nature to develop, to generate energy. Microhydric option was provided as a potential modular electricity generation system, which requires very low maintenance. And this, in combination with solar, it can provide the required energy in a isolated area or off-grid system. The need for local involvement have been emphasized. Again, this talk to community involvement. Through the local construction force, if there is a need for us to develop or to construct, it is always important to involve the communities. Some of us, we talk about security of the infrastructure. When community feel involved in the construction of any development, they will also take responsibility to safeguard the security of this infrastructure. And where they feel isolated from the process, the vandalism rate usually become very high. There was also a presentation from Waterloo who highlighted the challenges and opportunities associated with both biogas and water reuse. The opportunities for potassium recovery from brine in future, it's also something that they've highlighted. What was standing out was the operational gains associated with the smart lab. There was also a presentation by UNIDO, which specifically highlighted the value and importance of multi-stakeholder engagement. Again, community involvement is very much critical. Collaboration projects and partnerships were highlighted as part of the case studies presented by UNIDO, and also zooming into the training and capacity building in strengthening climate change adaptations by industries, where there was a specific mention of a case study in South Africa. The water energy nexus is key to minimize climate change impacts. There were a number of things that were said, but it is important to understand that some of those projects are geared towards addressing the climate change impact. Lastly, we had a presentation from CSIR, which looked at the implementations of nature-based solutions. The case study given talk about phycoremediation, which is a use of algae to treat wastewater. There are advantages and disadvantages associated with this technology, but we have already seen some of the positive results that are coming out from this technology. And the technology has been implemented for a number of years in South Africa, and some pilots have been implemented in other SADC countries, which are also showing some positive results. So with the harvesting of biomass of algae in this area, there is also an opportunity for circular economy and also an opportunity for biogas generation from this technology. Of course, there is an opportunity to implement some of the solar-powered bioreactors that both energy and water specialists can work together to make sure that there is very minimal utilization of electricity during the implementation of this technology. So from myself and Doris, thank you very much to all the speakers and yourself as the delegate who were part of this sessions, both part 1 and part 2 of these sessions. We are very grateful that we can see some of the faces that we saw from part 1 who are still here even during part 2. A sign that indeed the presentations were very interesting and talking to the type of work that we are doing. I will hand over to Doris to formally close the session.
Thank you, Rembo. I don't have much more to add because I think Rembo did a very good job in summarizing the key messages. I do want to thank you all for your participation, and I hope that you have found that the presentations the topics were interesting, and now you have the contacts, and it's the next step, looking forward for further developments. Thank you, everyone. Have a good lunch.